And then our last speaker of the session is Maximilian Mosberg from Notion Systems.
All right, good afternoon. Thank you all for having me. I want to start out with a quick personal introduction. So my name is Max. My background is in mechanical engineering, where I worked in the R&D for additive manufacturing of big plastic parts up to 1.5 years ago when I joined Notion Systems. So until 1.5 years ago, as a mechanical engineer, I've never heard of micron or nanometers, or I didn't know how electronics worked, and it was much, much more simpler time. But about 1.5 years ago, I got roped into the business development and sales team, sales role at Notion Systems. Notion Systems, we're based in Germany. We're a team of about 75 employees, where we live and breathe Inkjet, and that's what we do every day. The goal of my talk today is kind of to give you a quick crash course on Inkjet and EHD. And luckily enough, or bad enough for me, a lot of my previous speakers who had fantastic presentations touched on some of the subjects I want to talk about today. So this will make it much easier for me, in a sense. So let's start off with the PCB, as just introduced with Mrs. Strobel, how is this manufactured traditionally? So this is a traditional manufacturing process based subtractively. You start off by, you have your substrate, you have some kind of pre-treatment on the substrate. Afterwards, you apply material to the substrate homogeneously over the whole surface. Then you do a homogeneous drying. Afterwards, you do some kind of exposing. This can be an LDI. Then you have a developing. And during this developing stage, you waste a lot of the material that you applied in the first place. It could be up to 90%, 80% of the material. And you're losing very aggressive etching agents in this stage and wasting a lot of water. And afterwards, you have a final cure. And if you think about it, this process is very wasteful of all these resources I just mentioned. And especially nowadays, when you have to really think about working ecologically and economically, it's kind of at a point in time where we have to change, especially when we're thinking about bringing all these technologies back to Europe, bringing all these technologies back to the States with all these enactments nowadays. It's a good time for us to use a different approach. And one of these approaches we're proposing is to use Inkjet. So what is Inkjet? So Inkjet is a means to eject picoliter droplets of fluid out of a jetting nozzle. So what you see on the top here is a very, very oversimplified schematic of how one of these piezo-based printheads works. You have a piezo element in that printhead that flexes, introduces energy into our ink, and ejects individual droplets. Kind of give you a sense of scale we're looking at. We're usually looking at around a 20 to 30 micron droplet that's being ejected. And this can be this is very, very fast with up to 100 kilohertz per nozzle. So very, very fast process. This process is also highly scalable. So in one single printhead, depending on the manufacturer, you can have over 1,000 nozzles per printhead. And of course, in our printers, we can integrate multiple printheads. So we have one of our clients has over 60 printheads with over 1,000 nozzles each. So that's 60,000 nozzles that are to fire. And this is something we have to be able to control. We have to be able to place these droplets accurately on every position. So this is a fully digital process. And this is what we offer our clients. Let's look at this process again. What does the same process look like with Inkjet? Here, again, we have a pre-treatment. And this is something to be very transparent about, that this pre-treatment process usually differentiates from the classic pre-treatment. The reason being is that we have to be able to control the surface energy of the substrate. For example, to make it more hydrophobic. Why do we do this? We want to be able to control how the ink behaves on the surface of the substrate. If, for example, we have a hydrophobic surface instead of a hydrophilic one, we will have a very, very fine droplet on the surface that won't flow uncontrollably. So this is the first thing we have to take care of. Afterwards, we do a printing. This is fully digital, but we print and place every single droplet on the surface where it's needed. We don't waste any material. And afterwards, we have a cure, and we're done. So as you can see, this process is much more streamlined in comparison to the traditional manufacturing process. And again, if you think about it in process and numbers, what do we have here? We have a much lower consumption of material. because we only placed it where we needed it in the first